Today we're looking at topic 12-7, and we're going to learn about three-dimensional figures. Before we talk about 3D figures, let's remember what 2D figures are. So a two-dimensional figure has exactly that, 2 dimensions. It has a length and a width. Some examples of 2D figures would be a triangle, a square, a circle, a hexagon, a pentagon, a parallelogram, anything along those lines. It just has a length and a width. Length and a width. There's only 2 dimensions there. So the difference between 2-dimensional and 3-dimensional is that 3D figures have a length, a width, and depth, or the height. So last year you learned about rectangular prisms and you learned how to find the volume of rectangular prisms. We'll talk more about rectangular prisms today as well. So some examples of 3D figures that you've learned about in the past are cubes, prisms, pyramids, cylinders, spheres. In order to identify properly a 3-dimensional figure, we need to understand some terminology. The first term that we need to understand is the face. The face of a 3-dimensional figure is any flat surface. So here I have a rectangular prism. This is a flat surface. That's a face. There's 2. There's 3. There's 4. There's 5. And there's 6. So the rectangular prism has 6 faces. There's also a special kind of face. It's called the lateral face. And the lateral face is the sides. Basically what it's saying is if you remove the bases, then you have the lateral face. So before I go to lateral face, let's clarify on the bases. So on this one, we could say that we have a base here, and a base there. So if I remove the bases, I take away 2 of the faces. And the faces that I'm left with are the lateral faces. So the lateral faces are the faces when you take off the bases. So now I have a base here and a base on the bottom. I have 1, 2, 3, 4 lateral faces. Okay, the edge is the segment formed by the intersecting faces. So if I have this face here and this other face, this right here is the edge. So here is my edge, right there where the 2 faces intersect. It's that line. This particular prism has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 edges. Okay, a vertex is where the edges intersect. So I have an edge here, and I have an edge there. This point right here is the vertex. The vertex would also be known as the corners. You might want to write that down. The vertex is the same thing as a corner. So I have 4, 5, 6, 7, 8 corners, or 8 vertices on this prism. The plural for vertex is vertice. It's written right here. Okay, the base of the shape, as we talked about before, those are the top or bottom faces. And we use the bases to actually name the figures. So we already looked at the rectangular prism. Now we can look at a triangular prism. So here I have the triangular prism. And if the base is what names the figure, then I'm looking for triangles. There's base 1. And there's the other base. So on the triangular prism, we found the bases. Let's go back and remember the lateral faces. The other pieces would be the lateral face. So here's a one lateral. There's the second lateral. And there's the third lateral. So my triangular prism has 2 triangular bases and 3 rectangular lateral faces. We have 2 types of 3D figures. We have prisms and we have pyramids. We also have spheres, but that's in a different part of the video. So prisms and pyramids, let's differentiate the 2. The characteristics of a prism is that a prism has at least 3 lateral faces that are parallelograms. Okay, like the triangular prism, it has 1, 2, 3 lateral faces. The faces are parallelograms. The top and bottom faces are the bases. They are congruent and they are parallel. So my triangular prism, the triangle for the top base is congruent to or equal to the triangle for the bottom base, and they're parallel to each other. If we had a plane that went out forever and ever on the bases, those bases would never intersect each other, which means that each of the edges is also congruent. And as we discussed before, the shape of the base tells the name of the prism. So an example would be a rectangular or triangular prism, and we've looked at examples of both of those already. So I'm showing here a rectangular prism and a triangular prism. So right here, since it's called a rectangular prism, I've shaded in the base. These are both bases. Could I use the top and bottom? Sure. Or the sides. It doesn't really matter in the rectangular prism. So these are the bases of the prism. I've shaded those in. This is a triangular prism. The bases of the triangular prism have to be the triangles because it's called a triangular prism. So the bases of the triangular prism are the triangles, and those are shaded in as well. There's also a square prism, which is also called a cube. The special thing about the square prism, all the edges are congruent to each other. Every single side is congruent. It's made up of 1, 2, 3, 4, 5, 6 squares. Okay, so what about pyramids? Well, a pyramid has also 3 lateral faces, but the faces, instead of being parallelograms, are triangles. So a prism is has parallelograms for faces, and a pyramid has triangles for faces. I have a pyramid right here. There are 1, 2, 3 lateral faces, and all 3 of them are triangles. 1, 2, 3. They have only one base, and that base is a polygon. So this is a triangular pyramid, which we're most used to seeing. I have a square pyramid with a square base, but the faces are all still triangles. 1, 2, 3, 4 triangles. This is also a pyramid. It has 1, 2, 3, 4, 5 faces. And it's a pentagonal pyramid. So the base of your pyramid can be any shape as long as it's a polygon. And the number of sides of the base is going to tell you how many actual faces you have. And the name of this base, again, tells you the name of the pyramid. So a triangular pyramid, this is one view of a triangular pyramid, and you can see the base right here is a triangle. Where the rectangular pyramid, here is the base, and that's a rectangle. Rectangular pyramids have 4 lateral faces, where a triangular has 3 lateral faces. some other 3D figures and they have curved surfaces instead. And those are cones, cylinders, and spheres. So I have an example of a cone right here. We've all seen an ice cream cone. It has a round surface and it has a circular base. A cylinder, a circular base, and again, a round face, round sides. And then a sphere, which looks like a ball. That's the end of lesson 12-7. You need to do some U-Try, so you'll want to go ahead and U-Try section 12-7 in your workbook. And this time I'm going to put the answers on our website and you can download the answers.